Hey everyone, and welcome to another deep dive. I love to explore these big ideas, and today we're tackling a fascinating YouTube video called What is the Ultimate Cosmic Limit from the channel History of the Universe. And we're going to grapple with some pretty huge questions like, how much can we ever know about the universe? Are there hard limits to our understanding? Could things like physics or even our own brains put a cap on what we can figure out?
Yeah, and what's really interesting about this video is it doesn't just focus on the limits of science and technology. It actually dives into the limitations of human biology too, and even the very nature of knowledge itself. It's pretty wild. We're talking about things like a particle collider, the size of our solar system. Can you imagine that?
Whoa. Okay, my mind is already blown.
Yeah, and it gets even crazier. It talks about the possibility of hitching a ride on rogue asteroids, how Oumuamua zipped through our solar system a while back.
Right.
Well, maybe some super advanced civilization is already using those as interstellar taxis.
Okay, I am so ready for this.
And then it gets even more mind-bending. The video even explores the implications of an infinite multiverse. So there could be countless versions of you and me out there somewhere.
Hold on, an infinite multiverse. So you're saying there could be countless versions of me also listening to this deep dive right now? That's a lot to process.
It really is. It makes you question, what even is reality? But before we jump into the multiverse rabbit hole, the video kicks things off with something called the Kardashev scale. Have you heard of that?
I've heard of it, but to be honest, I'm a little fuzzy on the details.
Okay, well, it's basically a way to imagine how advanced a civilization could become based on how much energy they can use. Think of it like levels. A Type 1 civilization can use all the energy of their planet. Type 2 can harness the power of their entire star. And Type 3, well, they've figured out how to control the energy of their whole galaxy.
A galaxy-powered civilization. That sounds straight out of Star Wars.
It does, right? It's mind-blowing.
Yeah.
But the video makes a really interesting point. Even if a civilization reaches Type 3 status, galactic superpowers, they'd still be limited by their biology.
That's so true. I mean, even if we're zipping around the galaxy in spaceships, we still need to eat and sleep and, not get sucked into black holes.
Exactly. And the video really hones in on the limitations of the human brain. Our memory capacity, how fast we can think, and even just the fragility of our bodies makes you wonder, could we ever break free from these biological chains?
It's like a fundamental constraint, isn't it? Even if we could solve all the technological challenges, there's still the human element to consider. Our own biology might be the ultimate bottleneck.
Right. It's a bit of a humbling thought. But then the video takes us even further down the rabbit hole.
Yeah.
It starts talking about things like uploading our consciousness into a computer or merging with artificial intelligence. Like straight up sci-fi stuff.
Okay, now that's where things get really interesting. I mean, how realistic is that? Is that just pure science fiction, or could that actually be our future?
Well, that's a big question, isn't it? And the video doesn't shy away from those big, bold ideas. It even mentions Project Orion. Have you heard of that?
No, fill me in.
Okay, so this was a real project back in the 1950s. They were seriously considering using nuclear bombs to propel spacecraft.
Nuclear-powered spaceships. Wow. Talk about thinking outside the box. Can you imagine the debates if that had actually happened?
It would have been wild, wouldn't it?
Yeah.
But it shows you how far people were willing to go to explore the universe.
Mm-hmm.
And the video also talks about those generation ships. The ones we see in sci-fi movies all the time.
Those massive ships where people live and die on board, traveling for centuries to reach another star.
Exactly. And the video really delves into the challenges and the possibilities.
Yeah.
Like creating a self-sustaining world inside a spaceship, hurling through the void for generations. Mind-boggling.
And then there's that whole idea of hitching a ride on a rogue asteroid, like we were talking about at Oumuamua earlier. Maybe that's not as crazy as it sounds. Maybe some advanced civilization is already doing that.
Maybe they are. It's so fun to speculate. But speaking of interstellar travel, there's something that's always bugged me. Time dilation.
Mm-hmm.
That whole idea that time slows down when you travel near the speed of light?
Oh, yeah. That's definitely a mind bender. But is that actually a real thing, or is that just science fiction?
Time dilation is 100% real. It's backed up by Einstein's theory of relativity and tons of experiments. The faster you move, the slower time passes for you compared to someone standing still.
Wow. So it's like a cosmic cheat code almost, bending time itself. Could we actually use that to shorten interstellar journeys?
Well, theoretically, yes. But here's the catch. Reaching even a fraction of the speed of light would take a crazy amount of energy, way more than we can produce with our current technology.
So it's like time dilation is real, but using it for interstellar travel is still a distant dream.
Yeah, it's a bit of a bummer.
Yeah.
But hey, maybe someday, right?
So we've talked about the limits of our bodies and the crazy distances between stars, but what about the universe itself? Does the universe itself put any limits on how much we can?
That is a great question. And that's where the video takes us next. It reminds us that even though the speed of light is mind-bogglingly fast, it's still a speed,
Yeah.
Which means there's a horizon beyond which we can't see because the light from those distant regions hasn't had time to reach us yet.
So it's like there's a cosmic curtain hiding parts of the universe from us because they're just too far away. That's both fascinating and a little frustrating. It's like knowing there's a whole other world out there, but we can't get a peek.
It is kind of like that. And to make things even more complex, the universe is expanding. So some galaxies are actually moving away from us faster than the speed of light.
Wait, hold on. Didn't you just say that nothing can travel faster than light? How can galaxies be outrunning light?
Okay, you're right. Nothing can travel through space faster than light. But the expansion of space itself is a different story. Imagine dots on a balloon. As you inflate the balloon, the dots don't move across the surface right, but the space between them increases. If the balloon expands fast enough, two dots can effectively move apart faster than light, even though neither dot is breaking the speed limit within its local space.
Okay, that's starting to make sense, but it's definitely stretching my brain. So you're saying there are parts of the universe that are basically lost to us forever.
That's one of the mind-blowing takeaways from this video. There are limits to what we can observe, even with the most powerful telescopes we could ever imagine. And that brings us to a concept called cosmic variance. Imagine you're trying to understand the entire ocean, but you're only studying a single bucket of seawater.
That's a great analogy. We're trying to piece together the entire universe with a limited view. We're like cosmic detectives working with only a few.
Exactly. And it gets even weirder when you start to consider the world of quantum mechanics. Things get really fuzzy down there.
Oh yeah, quantum mechanics. That's where my brain usually starts to melt.
Yeah, it can be pretty mind-bending. One of the fundamental principles of quantum mechanics is the Heisenberg uncertainty principle, which basically says you can never know both the position and momentum of a particle with perfect accuracy.
I vaguely remember that from physics class, but it always seems so counterintuitive. How can you not know where something is?
Well, it's not about our ability to measure things. It's actually a fundamental principle of the universe itself. It's like the more you try to pin down a particle's location, the less you know about how it's moving, and vice versa.
So it's like there's a fundamental blurriness built into reality at the smallest level.
Exactly. And this blurriness has some pretty wild consequences. For example, it means that even if we knew all the laws of physics perfectly, we still couldn't predict the future with 100% accuracy because of this inherent uncertainty.
Hold on, are you telling me the universe is fundamentally unpredictable?
That's one of the big takeaways from quantum mechanics. It challenges all those classical ideas about cause and effect. At the most fundamental level, the universe is inherently probabilistic. We can only talk about the likelihood of certain outcomes, not guaranteed certain.
Okay, I need a minute to process. We've gone from galaxy-powered civilizations to a universe that might be fundamentally unpredictable. Maybe we need to take a break and come back to my brain is officially fried.
I hear you. It is a lot to take in. But actually, we should keep going, because we're about to dive into what are the most mysterious objects in the universe.
Black holes.
Black holes.
Yeah.
Okay, I'm intrigued but also a little terrified. Those are like the ultimate cosmic limit, right? Places where gravity is so strong that nothing, not even light, can escape.
Exactly. They're like cosmic vacuum cleaners sucking up anything that gets too close.
Mm-hmm.
But they're also incredibly fascinating when you think about them from a knowledge perspective. The video describes them as these giant information repositories, but also as regions where information is seemingly locked away forever.
Wait, what do you mean by information repositories? Isn't everything that falls into a black hole just crushed and destroyed?
That's what we used to think. But physicists are starting to think about black holes in a whole new way. They're still incredibly destructive, of course, but they might also be preserving information in some strange quantum way.
So they're like giant cosmic libraries, but the books are written in a language we can't understand. That's a great way to put it. And that actually leads to another intriguing question. If information can be trapped inside a black hole, what about the past? Is information about past events also inaccessible to it, except through things like limited records and artifacts?
You're saying the past is like a black hole where information is lost forever.
Well, not exactly. We can still learn about the past,
Huh.
through things like fossils and historical records and even astronomical observations. But from a physics perspective, the past is kind of like the interior of a black hole.
Oh.
Once an event has occurred, it's gone. We can only observe its effects in the present.
That's so trippy. So even if time travel were possible, we could only visit the past as observer, not actually change it.
Yeah, that's the paradox of time travel, isn't it? If you could change the past, you'd create all these inconsistencies that would just unravel everything. Fun thought experiment, but it seems like the past, like the inside of a black hole, is ultimately beyond our reach.
Okay, so we've talked about the limits of our biology, the vastness of the universe, speed of light, the fuzziness of quantum mechanics, and the information-gobbling nature of black holes. Is there anything else out there that could limit our quest for knowledge?
Oh, you've saved the best for last. The video ends with a truly mind-blowing concept, the multiverse. The idea that our universe is just one of many, maybe an infinite number of universes, all coexisting in some higher dimensional space.
The multiverse, I've definitely heard of it. Different universes with different laws of physics, maybe even different versions of ourselves. It sounds so crazy.
I know, right? It's crazy awesome. And this is where things get really interesting. Because this idea of a multiverse leads to something called the measure problem. If there are an infinite number of universes out there, how do we make any meaningful statements about the rarity or commonness of any feature of our own universe?
I see what you're saying, because in an infinite multiverse, every possibility would exist somewhere.
Right.
So even if we could gather all the information in our own universe, it would be meaningless in the grand scheme.
Exactly. That's the unsettling thought the video leaves us with. The very concept of an infinite multiverse could actually render all our knowledge ultimately insignificant.
Yeah.
It's both humbling and awe-inspiring to think about.
Wow, that is heavy stuff. We've covered so much ground already. From the limits of our own brains to the possibility of infinite universes, it's almost too much to process.
I know, right? It's a lot to take in. But I think we've only scratched the surface of this fascinating topic. There's so much more to explore.
You're right. We'll definitely need to pick this conversation back up in our next deep dive. But for now, let's leave our listeners with a thought-provoking question. If an advanced civilization created a new form of intelligent life to gain a different perspective on the universe, what might we learn from them? Or even more intriguingly, what might they learn from us?
It really makes you think. You know about what intelligence even means and how our own perceptions shape our understanding of the universe. It's like, are we limited by our human way of thinking? But before we go too far down that rabbit hole, let's bring things back down to Earth for a bit.
Okay, I'm game. What else did this video unearth about, the limits of knowledge? Did it talk about any specific examples from history?
It did. The video takes us way back to the dawn of human history. When our ancestors first started noticing those patterns in the world around them.
Right, like the changing seasons or the movement of the stars.
Exactly. They started using those patterns to develop things like rituals and calendar. They could even predict events like eclipses.
So even way back then, humans were already trying to understand the world around them. It's like they were the original scientists.
I love that. The original scientists. You're totally right. And the video even talks about this incredible artifact, a 32,000-year-old ivory tablet. It might be one of the earliest examples of scientific thinking we have.
Whoa, 32,000 years old. What's on this tablet?
Well, it seems to have these markings that track the movements of the constellation, Orion, and some researchers think it could even be linked to the length of a human pregnancy.
A 32,000-year-old star chart. That's incredible. It's like a direct link to the minds of our ancient ancestors.
It really is. And it shows that they were already grappling with some pretty complex ideas, about time, astronomy, maybe even biology.
It just shows you that science is a fundamental part of what it means to be human. This drive to understand the universe. It's been with us from the very beginning.
Absolutely. And the video even suggests that ancient myths and stories could be seen as a kind of proto-science,
Like those stories about gods and goddesses controlling the weather or the sun and the moon.
Exactly. They were early attempts to explain the world, even if they didn't always get the facts right.
They were working with what they had right. It makes you wonder what future generations will think about our current scientific theories. Like, will they look back at us and think, wow, they were so primitive?
It's totally possible. I mean, that's kind of the beauty of science, right? It's always evolving. We're always learning and revising and pushing the boundaries of what we know. What we consider truth today could easily seem like a silly myth to people 1,000 years from now.
It's a good reminder to stay humble. But speaking of pushing boundaries, the video jumps ahead to Galileo. He's often considered one of the founders of modern science. What made him so revolutionary?
Well, Galileo was a true visionary. He was one of the first to really use mathematics to describe the natural world, to make predictions about how things work. He believed that the universe was written in the language of mathematics, and he set out to decipher that language.
I remember learning about Galileo's experiments with falling objects. You know how he challenged the idea that heavier objects fall faster?
Oh, yeah, that was a classic. So back then, people thought heavier objects fell faster because they had a greater affinity for the Earth. It seemed logical at the time.
It does kind of make sense when you think about it.
Right. But Galileo wasn't satisfied with just logic. He actually did the experiments. He carefully dropped objects at different weights and measured their descent.
And he found that they all fell at the same rate.
You got it. It was a groundbreaking discovery. It showed that logic and observation, guided by math, could actually overturn even the most deeply held beliefs. It was a pivotal moment in the history of science.
It's such a great example of how science can challenge our assumptions about the world. We need to be willing to question what we think we know and be open to new ways of seeing.
Couldn't agree more. And Galileo's emphasis on math, it's something that's still shaping science today. Think about Einstein's famous equation. That simple equation actually encapsulates a mind-boggling amount of information about the relationship between energy and...
It's amazing how a few symbols can hold so much meaning. But it's not enough to just memorize equations, right? You have to really understand the concepts to appreciate their power.
Exactly. Mathematics is a language. And just like learning any language, you need to learn the vocabulary and the grammar to understand what's being said.
So we've gone from ancient stargazers to Galileo and Einstein. But what about more recent examples? Did the video talk about any breakthroughs that have helped us push the boundaries of knowledge even further?
Oh, absolutely. The video actually traces the evolution of our understanding of lightning, from ancient myths about gods throwing thunderbolts to Benjamin Franklin's famous kite experiment.
Oh yeah, the kite experiment, that's a classic.
Right. It's so simple yet so profound. Franklin proved that lightning was actually electricity, which was a huge revelation at the time.
It really sparked a revolution in our understanding of electricity, didn't it?
It did. It led to all sorts of discoveries, like batteries, electric motors, and eventually the whole field of electromagnetism, all thanks to a kite and a...
It's amazing how one seemingly small discovery can have such a huge ripple effect. It makes you wonder what simple experiments we're doing today that could lead to similar breakthroughs in the future.
Right, it's so exciting to think about. But the video also brings us back down to earth a little bit. It reminds us that despite all the progress we've made, we still have so much to learn. It points out that even our most advanced scientific theory, like our current understanding of gravity, are likely to be refined and maybe even completely overturned as we gain new knowledge.
So even though we've come so far, we're still just scratching the surface. That's a little daunting, but also kind of exciting. It means there's still so much out there to discover.
Exactly. And it highlights the importance of staying curious and open-minded. But then the video shifts gears a bit and starts to focus on one of the biggest limitations we face in our quest for knowledge, our own biology.
Right. We're talking about the limitations of the human brain. Even if we had all the time and resources in the world, our brains can only hold so much information. We can only process things so quick, and we need very specific conditions to survive.
It's true. We're these incredibly complex beings, but we're also incredibly fragile. The video mentions this one study where the longest anyone stayed awake was about 19 days. Can you imagine trying to wrap your mind around the vastness of the universe when you can barely stay awake for a week? Talk about a hard limit.
It really puts things in perspective. It makes you wonder if we'll ever be able to transcend those limits. You mentioned earlier some pretty wild ideas like uploading our consciousness to computers or merging with AI. How far-fetched are those ideas?
Well, those are definitely some mind-bending concepts. I mean, they're still pretty speculative. But even if those ideas stay in the realm of science fiction, there are other ways we might be able to extend our reach, using technology to enhance our senses and expand our cognitive abilities.
Like using telescopes to see distant galaxies or microscopes to explore the microscopic world.
Exactly. We've already come a long way in that regard. Think about it. Galileo's first telescope only had a magnification of about 8 times, which is less powerful than a pair of binoculars you can buy today. Now we have telescopes like the James Webb Space Telescope, which can see objects billions of light years away.
It's amazing to think about how far we've come in such a relatively short time. And what about the microscopic world? How much have we learned about that realm?
Oh, we've made incredible progress there too. The video mentions that we now have microscopes powerful enough to see individual atoms. It's like being able to look directly at the building blocks of matter. And these advancements aren't just about seeing things, they're also about understanding them. We now have computer simulators that can model all sorts of things, from the folding of proteins to the evolution of entire galaxies.
So it's not just about extending our senses, it's also about extending our minds, using technology to boost our ability to think and analyze and make sense of the universe.
Precisely. And it's important to remember that this quest for knowledge isn't just some abstract pursuit. It has very real-world implications. The more we understand about the universe, the better equipped we are to solve problems, develop new technologies, and ensure the long-term survival of our species.
That's a really great point. So even though there are limits to what we can know, we shouldn't lose sight of the incredible progress we've made and the boundless possibilities that lie ahead. But I'm also curious about some of those more speculative ideas the video touched on. What about interstellar travel? Did it offer any potential solutions to that huge challenge? The idea of interstellar travel has always been so fascinating to me, but it just seems so impossibly far away, even to the closest stars. What did the video suggest? Are there any realistic possibilities for bridging those huge gaps?
Yeah, the video explores a bunch of possibilities, ranging from those that seem pretty practical to some that are pretty out there. One that always gets me thinking is the concept of generation ship. Those massive self-sustaining spacecraft that could carry whole communities on journeys to distant stars.
Generation ships. I love that idea. Creating a whole miniature world inside a spaceship, a closed ecosystem where people live and work and, raise families, all while traveling through the vast emptiness of space.
It's a pretty wild concept, right? And it raises all sorts of questions like, how do you even maintain a stable society over such a long period of time? What kind of culture would develop in such an isolated environment? Is it even ethical to subject generations of people to life confined within a spaceship?
It's like a giant social experiment on a cause. But the video also talked about some other really interesting ideas like using rogue asteroids for interstellar travel.
Oh yeah, the Oumuamua solution. It's a bold idea, that's for sure. Instead of building a spaceship from scratch, we find a suitable asteroid that's already cruising through interstellar space, and we just hitch a ride.
That sounds crazy, but I kind of love it. It's like nature has already provided us with these ready-made spaceships, just waiting for us to claim them. Transforming a barren rock into a habitable environment would be a huge challenge, of course.
Yeah.
But it's not totally impossible, right?
Not totally. And then there's the idea of harnessing time dilation. As we talked about earlier, time slows down for objects traveling at speeds approaching the speed of light. So if we could somehow reach those incredible velocities, we could potentially make interstellar journeys much shorter, at least from the perspective of the travelers.
So it's like a cosmic cheat code bending time itself to make those distances a little less daunting. But didn't you say that the energy required to reach those speeds would be astronomical?
It would be a massive undertaking, no doubt about it. We're talking about technologies that are way beyond anything we can do right now. But, the video encourages us to think big, to imagine what might be possible if we could overcome those technological hurdles.
I like that think big. It's a good reminder that even though there are limits, there's also incredible potential for innovation and discovery. But the video doesn't just focus on the exciting possibilities, it also acknowledges the hard reality. It points out that no matter how advanced we become, there will always be limits imposed by the universe itself.
And that brings us back to the concept of finite knowledge. The video emphasizes that the observable universe, the part we can actually see, is limited by the speed of light and the age of the universe.
Right. Even if the universe is infinite in size, there hasn't been enough time for light from the most distant regions to reach us. It's like a cosmic horizon beyond which we can only speculate.
And remember, the universe is expanding, which means that some of the galaxies we can see today will eventually fade from view as they move away from us faster than the speed of light. It's like our cosmic window of observation is slowly shrinking.
Kind of a sad thought. Does that mean the amount of information potentially access is constant?
In a way, yeah. But it also highlights how precious the knowledge we do have is. It's a reminder to appreciate the incredible insights we've gained so far and to keep pushing the boundaries of what we know while we still can.
So even though we're limited in what we can see, there's still an incredible amount of information within.
Absolutely. Okay. The video estimates that there are somewhere between 500 billion and 2 trillion galaxies in the observable universe, each containing billions of stars. It's an almost unimaginable amount of information just waiting to be explored.
That's mind-blowing. But let's say we could somehow observe and catalog every galaxy, every star, every planet in the observable universe. Would we have complete knowledge then?
That's a great question. And the answer, surprisingly, is no. Even if we had this complete map of our universe, it would only tell us about the specific arrangement of matter and energy within our own little cosmic bubble. It wouldn't necessarily reveal the underlying laws of physics that govern the multiverse as a whole.
So it's like knowing the contents of a library, but not understanding the language the books are written in.
Exactly. And that brings us to what the video calls the ultimate limit to our knowledge, the concept of infinity, particularly as it relates to the multiverse.
Right, the multiverse. The idea that our universe is just one of many, maybe an infinite number of universes existing in some higher dimensional space.
Precisely. And if the multiverse is truly infinite, then it would contain an infinite number of variations of everything, including you and me.
Infinite versions of me out there somewhere. That's both terrifying and oddly comforting. But if there are truly infinite possibilities, how can we ever hope to understand the bigger picture? How can we make any meaningful generalizations about reality if there are infinite variations of everything?
That's the heart of the measure problem, which we talked about earlier. In an infinite multiverse, any attempt to quantify the rarity or commonness of any feature of our universe becomes meaningless.
It's like trying to measure the depth of the ocean with a ruler. The wrong tool for the job.
Exactly. And it really highlights the limitations of our current scientific framework. We've developed these incredibly powerful tools for understanding our own universe, but they might not be adequate for grappling with the complexities of a multiverse.
So even though we might face these limitations, it doesn't mean we should stop searching for answers, right?
Absolutely not. The video actually ends on a hopeful note, suggesting that there might be other ways of understanding the universe beyond the traditional scientific method. It even touches on the potential of AI, artificial intelligence, to perceive the cosmos in ways we can't even imagine.
So even though we might face all these limitations, biological, technological, and maybe even cosmic, there's still this sense of wonder and possibility.
That's the beauty of it. The universe is full of mystery, and our quest for knowledge is a never-ending journey. We might never have all the answers, but the pursuit itself is what makes it so fascinating.
This has been an incredible deep dive. We've covered so much, from the earliest stirrings of human curiosity to the mind-boggling concept of an infinite multiverse. It feels like my brain has expanded.
Mine too. It's a great reminder that even though there are limits to what we can know, there's an unlimited capacity for wonder and exploration.
Well said. And who knows what amazing discoveries await us as we continue to explore the universe and try to understand our place within it. Thanks for joining us on this cosmic adventure.
Until next time, keep exploring, keep questioning, and never stop wondering.